Next one, example 2.18. In a hydrogen atom, the electron and proton are bound at a distance of about 0.53 angstrom. Question A. Estimate the potential energy of the system in electron volt, taking the zero of potential energy at infinite separation of the electron from proton. B. What is the minimum work required to free the electron, given that its kinetic energy in the orbit is half the magnitude of potential energy in A? C. What are the answers to A and B above if the zero of the potential energy is taken at 1.06 angstrom? Now see here, first if we consider the zero of the potential energy at infinite separation, it implies that now we can write the equation for the potential energy, that is K Q1 Q2 upon R1 2. Now see, charge Q1, that is charge of proton, so that is E, and that is 1.6 into 10 raised to minus 19 coulomb. Then another charge, that is charge of electron, that is minus E, that is minus 1.6 into 10 raised to minus 19 coulomb. Then separation between those two, that is 0.53 angstrom, that is 0.53 into 10 raised to minus 10 meter. Now, in first case, we have to take the zero of the potential energy at infinite. So whatever is the total work done to assemble this system is stored in it in the form of potential energy. And for that, in theory, we already derived the equation, that is K Q1 Q2 upon R1 2. So we can write U, that is equal to, now Q1 Q2, that is plus E and minus E. So our equation of potential energy will be minus K E square upon R1. So minus K, that is 9 into 10 raised to 9, E, that is 1.6 into 10 raised to minus 19 square of it, upon the separation, that is 0.53 into 10 raised to minus 10. If we solve this one, then answer will be minus 27.2 into 1.6 into 10 raised to minus 19 joule. Now, if we want to give the answer in electron volt, then we have to divide this one by 1.6 into 10 raised to minus 19. So potential energy of this system will come to minus 27.2 electron volt. Now, the kinetic energy in the orbit, that is half than the magnitude of this potential energy, that is given to you. So kinetic energy, that is half of magnitude of U. So half of 27.2, that is equal to 13.6 electron volt. Okay. Now, total energy of the system, that is kinetic energy plus potential energy. So kinetic energy, that is 13.6 electron volt. Potential energy, that is minus 27.2 electron volt. So resultantly, the total energy, that is minus 13.6 electron volt. Now, here, work done to make electron free. See here, total energy comes to negative. When total energy comes to negative, means the object is bound by this much energy. If you want to make it free, means you have to make its total energy, that is equal to 0. So if we supply the same amount of energy to it. Then it will be free. And now we can say, to make electron free, we have to do work, that is plus 13.6 electron volt. Clear to all of you up to this? Now see, in first question, it was given to you the reference position that we have to take at infinity. So at infinity, the potential energy is 0. So this second term was not taken in that first question. But now in second question, it is given to you, we have to take the reference position as the separation 1.06 angstrom. And now we have to calculate the potential energy of the system, then kinetic energy, and work done to make electron free. So now potential energy, that is K Q1 Q2 upon R1 minus K Q1 Q2 upon R2. So simply we can write K Q1 Q2 into 1 upon R1 minus 1 upon R2, where R2, that is the position for the zero potential energy, that is the reference separation, that is 1.06 angstrom, that is 1.06 into 10 raised to minus 10 meter. Now Q1 Q2, that is plus E minus E, so minus Ke square into 1 upon R1 minus 1 upon R2. So minus K, that is 9 into 10 raised to 9. E, that is 1.6 into 10 raised to minus 19 whole square. 1 upon R1. R1, that is 0.53 into 10 raised to minus 10 meter. R2, that is 1.06 into 10 raised to minus 10 meter. And from this bracket, 1 upon 10 raised to minus 10 meter is taken common, so it is written here. Now if you solve this one, then you will get the potential energy in terms of joule. Then if you divide it by 1.6 into 10 raised to minus 19, your answer will be in electron volt. Now potential energy, that is minus 13.6 electron volt. Kinetic energy will be half than this one. So kinetic energy, that is half of magnitude of potential energy. So half into 13.6, that is 6.8 electron volt. Now total energy, that is kinetic energy plus potential energy. So that is 6.8 minus 13.6. So that is minus 6.8 electron volt. So work done to make electron free, that is plus 6.8 electron volt. Clear to all of you?